Okay, this is how to assemble a thin layer chromatography chamber. You take one piece of filter paper, fold it in half, and then carefully tear it. And you need half to go into the beaker sitting at the bottom. That's going to act as a wick to allow solvent to fill the entire chamber. Then you just need a watch glass and put it on that way. If you put it this way, it's liable to slide off, so put it on that way. There's your thin layer chromatography chamber. Now we're going to prepare a thin layer chromatography plate. These are pre-cut for you. There is a shiny side and a matte side, M-A-T-T-E. That means not shiny. The not shiny side is the side that has a coating of silica, and that is the absorbent that the materials are going to flow through. So we're going to prepare this for putting a spot on by taking a ruler and making a line with a pencil, not a pen, about 1 centimeter above the bottom. And we want to write that very gently, otherwise you will scratch off the solid. In fact, you can see little chips there, which is okay, but that should help you see that those little chips are where some of that solid has chipped off. If you look on the other side, this is just the shiny piece of plastic. There's no coating on that. There's nothing you can do on that. Don't write on that side. Don't try to put spots on that side. Okay, now we're going to mark several lanes. For something, the normal width that I give you, you probably can fit about 4 spots. Those can be 4 different things, or they can be 4 of the same thing. And today, for this demo, we're going to do 4 of the same thing, but in the lab, you'll probably do 4 different things, 1 different spot. So you'll label these 1, 2, 3, 4, A, B, C, D, whatever you want. Okay, so this is ready to have the material put on it. Now let me show you how to prepare the spot. This happens to be a mixture of 3 different substances. I'm going to take a very small amount at the tip of my spatula and I'm going to put it in one of the well plates of this. And just for contrast, I'm going to put this underneath so that you can see it a little better. Now that's the solid mixture that I want to spot, but it's a solid. I have to dissolve it in a solvent. Acetone is a typically convenient solvent to use, so I'm just going to very carefully squirt a little bit of acetone, and you can either use the spatula to swirl it around or swirl it around just like that, and that has now made a solution that I'm ready to spot. This is hard to see on the camera. This is a very thin glass tube. This is why we need to wear goggles, because this could break off and get in your eye, and that ruins your day. So it's a very thin glass tube, and when I put it into the liquid, it's going to draw up by capillary action some of the liquid. Let's see if we can see that in the camera. Here we go. So I'm going to put this in, and it'll draw up some of the liquid. You see it there. Now, if I just touch this to the thin layer chromatography plate at the location of the mark, touch and let go, the solvent has flowed out, and you can see it changing color a little bit because the solvent is evaporating. So I'm going to do, in this case, as I said, I'm doing the same thing over and over, so I just touch it there, touch it there, touch it there. One thing you can do if you're spotting the same thing over and over is you can make one spot much more concentrated and one very, very light. So I'm going to come back after the solvent has evaporated and touch again. And maybe even a second time here, or a third time. And so this one is very concentrated, whereas these are less and less concentrated. Now, if I'm done with this, or for example, if I'm spotting other things after spotting with that, you can break this off. You just put your fingers like that and pull while pushing that way. This then goes into the glass waste, but you can put it into a small beaker at your lab bench until you're ready to dispose all of it. All right, so I've spotted, in this case, the same thing 4 times. I'm going to run it in the thin layer chromatography chamber, but now I have to choose a solvent mixture. The acetone that I used here has completely evaporated. What I put in here is not necessarily acetone, but a mixture of solvents. And if you put in 10 milliliters into this 400 milliliter beaker, it will be just below 1 centimeter so that we can put this in without those spots being underneath the solvent. So any solvent or mixture that you wish. So for example, I might put in hexane, and I'd put 10 milliliters of hexane. Or if I wanted to do 2 milliliters of hexane and 8 milliliters of dichloromethane, that also makes up a total of 10 and would be a ratio, and you can adjust the ratio. One of the things you'll do in the lab is test out different ratios of solvents in the solvent chamber. So I'm going to now go over to the instructor hood and fill this with solvent, 10 milliliters of solvent, but we're not going to reveal which solvent because that's up to you to figure out which is the best solvents for your system. So I'll be right back after filling that up. All right, so this is 10 milliliters of solvent, and I've swirled it so that the filter paper is completely wet with solvent. I'll cover it with the watch glass. So this now is going to saturate the chamber with solvent. Now I'm going to put this in. By the way, when holding this, you don't want to hold it with your finger because you'll get fingerprint on there that you can see with other techniques, even if it's invisible to visible light. So I'm going to take the plate with this forceps and I'm going to lean it against the side. You want it kind of vertical because if you put it too tilted, then it can fall in. And you also don't want to lean it on the paper because then possibly the solvent can wick from the paper onto the TLC plate. What you should be able to see now is where the wet part of the plate is. That's what we call the solvent front, and it's moving up the plate by capillary action. While it's moving up the plate, it is pushing some of the materials. Remember, what I spotted was a mixture of 3 substances, and so they're moving up the plate at different rates. And it's going to go all the way or almost to the top. I don't want it to go past, well, it won't go past the top, but if it goes all the way to the top, the solvent will continue to flow as it evaporates off the top, and then I won't know how far the solvent traveled. So we have to wait a moment as it travels up the plate, and you want to watch it because guarantee if you get distracted and do something else, it will run too long. So you always just watch it for a moment until it's, and if you can see that it's done a good separation, you can stop, but we're going to let it go just a little bit more. Okay, we're going to stop it here, and so I'm going to take it out with the forceps, and immediately upon taking it out, I'm going to use my pencil to mark where that solvent front is located. I just have to put a little tick mark, and again, very gently so I don't scratch off the solvent, and I'll keep this capped. I now need to let the solvent evaporate, and essentially that's when it stops looking wet. You can warm it in your hand. You don't want to breathe the fumes. It's very, very little, but we can, if we can do this in the hood or avoid breathing the fumes, that would be better. I can feel that it's cold because it's evaporating a solvent, and that's what cools things off. How you cool off is your sweat evaporates, and that's why you feel cold. That's also why when you jump into the pool and then stand up out of the pool, you feel cold. Even when you thought the water was cold, it's because when you stand up in the pool, then the water is evaporating from your skin and cooling you off. If you go all the way down to your neck, you're not going to feel that evaporation effect. Okay, so now the materials we've chosen to use in this experiment are all visible pigments. And so you should be able to see there's a little bit of a yellow right there. That's ferrocene. There's an orange right there, which is acetylferrocene, and then there's another substance at the bottom, diacetylferrocene. So this plate has shown a clear separation between ferrocene and acetylferrocene, but not as good a separation with the others. And this is a 1-to-1 ratio of solvent A and solvent B. But again, because I want you to figure out which solvents, I'm not revealing right now which solvents I used. Normally you would write 1-to-1 and then you'd write the names of the solvents so that another student, or when you repeat the experiment with a different solvent mixture, you can compare. If you run it 100% with solvent A or 100% with solvent B, what does it look like? This isn't the only way to visualize the materials. We have an ultraviolet lamp, and there's actually a pigment in the TLC plate itself that is fluorescent. So if I put the fluorescent light over it, everywhere that there is not an organic compound, the plate will fluoresce, but the organic compounds prevent the fluorescence. So if you can see here, this is sometimes a better way to visualize the spots. Remember, I said if you had 4 lanes, you could do the same thing 4 times with a more and then less concentrated, and you can see the result of that. The more concentrated one has a larger spot. Now, one more piece of the story. Once you've marked them with a pencil, you can measure the relative flow, the RF value. We're going to measure the distance traveled by the solvent. So from there to there is 3.1 centimeters. That's the distance traveled by the solvent. And then the distance traveled by this spot, I find the middle point of the spot, and that is 2.3. So the RF value for this one would be 2.3 divided by 3.1. But there's a spot here, and that one is really 0.3 millimeters. So that's 0.3 divided by the distance traveled by the solvent. And there's another one, this is essentially 0, right? Didn't move at all. So you can calculate that. I only did it for that lane, but the other spots are also along with it because that's the same substance in all 4 of the lanes. And likewise here, they're just smaller. There may be some variation in the distance traveled, in particular if the solvent doesn't travel in a flat line, but it wicks up the sides, then you can have edge effect problems, like if the solvent front looks curved. Ideally, it looks flat. Okay, so then you do this, you're going to change the solvent mixture or partner with someone else who ran a different solvent mixture, make a decision about yet another solvent mixture, and that is the first part of the lab, to determine how to separate. The next part of the lab, I will give you an unknown substance, which is a mixture of 1, 2, or all 3 of these, and then you will put that on a TLC plate and identify which substances are present based on the appearance of their TLC plate, once you know which solvent mixture is a good way to separate them.